Good morning, children. How are you, children? I hope all of you are fine. Today, class for sixth class. Subject is general science. Children, we are discussing about the second lesson, playing with magnets. In previous class, we discussed about the different shapes of the magnets. So that are bar magnet, ring magnet, disc magnet, horseshoe magnet. And we also discuss about the magnetic materials and non-magnetic materials. Magnetic materials means the materials that are attracted by the magnet are called as magnetic material. Example: iron pins, safety pins, jump clips, iron bolts, iron nails, etc. Non-magnetic materials, the materials that are not attracted by the magnet are called as non-magnetic materials. Example: plastic ball, eraser, wooden box, etc. Okay, today we are discussing about the some of the activity. Listen them carefully. Children, normally when you place the magnet in the soil, some fine particles are attached to the magnet. So these fine particles are called as iron fillings. Iron fillings. So to perform this activity, we need one bar magnet, white sheet papers, iron fillings. Iron fillings. First, take one white sheet of paper. First, take one white sheet of paper and spread some iron fillings upon the surface of the white sheet paper. First, you take one white sheet paper and spread some iron fillings upon the surface of the iron sheet. Place the bar magnet beneath the white sheet paper. Place the bar magnet beneath the white sheet paper. You would observe that the iron fillings are arranged on the paper in a particular manner. Okay, the iron fillings are arranged on the surface of paper in a particular manner when you place the bar magnet just beneath the white sheet of paper. Just beneath the white sheet of paper. And you also observe that on the two sides of the paper, more iron fillings are gathered. అంటే రెండు పేపర్ యొక్క కొనల భాగంలో ఎక్కువ ఐరన్ ఫిల్లింగ్స్ అనేవి వచ్చేస్తాయి when compared to that one middle part of the paper. Why? Because nothing but we are placing the magnet beneath the paper. So the ends of the magnet attracts more iron fillings. The ends of the bar magnet attracts the more iron fillings when compared to the central part of the magnet. We would observe that the two ends of the bar magnet attracts the more iron fillings when compared to the central part of the bar magnet. Means nothing but in the central part of the bar magnet attracts very less iron fillings towards it, but the ends of the bar magnet attracts more iron fillings. Okay, so we can say that one the ends of the bar magnets, the ends of the bar magnet that attracts or whose attraction is more, the ends of the bar magnet whose attraction power is more compared to the middle part of the bar magnet are called as poles of the bar magnet, are called as poles of the bar magnet. The ends of the bar magnet whose attraction power is very more compared to the middle part of the bar magnet are called as poles of the bar magnet. Poles of the bar magnet. Normally each bar magnet has two poles. One is north pole, another one is south pole. One is north pole and south pole. So the south pole of the bar magnet and the north pole of the bar magnet attraction power is very more when compared to the remaining part of the bar magnet. Okay, so the ends of the bar magnet whose attraction power is very more compared to the middle part of the bar magnet are called as poles of the bar magnet. Next activity to know about the directional property of the magnet. Directional property of the magnet. Okay. So the aim of the activity is to know about the directional property of the magnet. What is the aim? To know about the directional property of the magnet. Okay, to know about the directional property of the magnets. Material required: one laboratory stand, one laboratory stand, one bar magnet, one bar magnet, thread. What? Thread. Procedure: first take one bar magnet. First take one bar magnet and tie up the bar magnet with thread. And tie up the bar magnet with thread. Next, suspend the bar magnet to the laboratory stand. Suspend the bar magnet to the laboratory stand. And observe the movement of bar magnet carefully. We observe that the magnet always lies in north-south direction only. We would observe that the magnet always lies in north-south direction only. Result: when you suspend the bar magnet freely, at the time when you suspend the bar magnet freely, the magnet always lies in a north-south direction. This is called as a directional property of the magnet. It is called as directional property of the magnet. What? It is called as directional property of the magnet. Next, we are discussing about the magnetic compass. Magnetic compass. So, suppose we have magnet, but we didn't know the poles of the magnet. Means which end of the magnet is north pole and which end of the bar magnet is south pole. So, at the time, by using magnetic compass, we know the north pole of the magnet and the south pole of the magnet, and we are reaching at an unknown place. At the time, we didn't know about the direction of the place. At the time, when you place the magnetic compass in that place, it will show the directions perfectly. Okay. What is magnetic compass? Magnetic compass means nothing but one type of compass that is present in a glass box. అంటే గ్లాస్తో చేసిన బాక్స్లో ఉంటుంది. సో inside the magnetic compass, the south direction and north directions are marked. Okay, and in the magnetic compass, one needle is pivoted, means nothing but attached, and always that needle of the magnetic compass is freely moving. Always the needle of the magnetic compass is freely moving, and the entire setup is present, means covered by the glass material. Glass material. When you place one of the bar magnet that is not marked with the south pole and north pole, then we brought the bar magnet near the magnetic compass. At the time, the needle always indicates toward the north direction of the bar magnet. Opposite to that one, the south pole of the magnet is present. So in this way we determine the poles of the magnet. So normally where we use that magnetic compass? So when we travel in ships, అంటే పడవలో ప్రయాణం చేసేటప్పుడు, at the time we didn't know on which side is north direction, south direction or east or west. So at the time, by using magnetic compass, the sailors know the direction. Okay, and army people also use the magnetic compass to know the direction. Okay, in ships and army peoples and in submarines also we use the magnetic compass to know the direction of that place, the direction of that place. Okay, especially army people use this magnetic compass to know the direction of the place, and in ships also we use the magnetic compass to know about the direction in the oceans, and we also used in the aeroplanes. Okay, in aeroplanes also we use the magnetic compass to know the direction. In submarines also we use the magnetic compass to know about the direction of the particular area. Okay, sometimes asking where do you use the magnetic compass? We use the magnetic compass in army field, means nothing but army people use the magnetic compass to know about the direction. In ships, aeroplanes and submarines we use the magnetic compass. Okay, in this video we know about that one. When you suspend the magnet freely, it always lies in north pole south pole direction. So this property of the magnet is called as the directional property of the magnet. Okay, when you freely suspend the magnet freely, at the time the magnet always lies in north pole and south pole direction. This is called as the directional property of the magnet. Okay, so this is about the magnetic properties. Okay, this is about the what? Magnetic property. Later we have to discuss about the attraction power of poles of the magnet, means the attraction power of the north pole of the magnet, and we also know about that one attraction power of the south pole of the magnet. Okay, what happens when you place means when you bring together one magnet near to the another magnet. Okay, thank you children.